Hello there, we are from Group 2 Section 4 of Operating Systems subject. In this presentation, we are actually going to discuss about our project. We're going to introduce the topic a little bit. We're going to also talk about how we collaborated and how we allocate our tasks. And also lastly, we're going to talk about a case study that relates to our topic. So our topic is actually related to process coordination. So what exactly is process coordination? Process coordination refers to the task of coordinating process executions so that executions lead to shared data consistency. So process coordination actually deals with two concepts. The first is mutual exclusion, where it is a mechanism to prevent concurrent or simultaneous access, and synchronization, which is actually a more generalization of mutual exclusion, and it uses conditions to coordinate concurrent processes. So when do we use process coordination? So a good environment to use process coordination is when we have two or more processes that actually access the same shared data or resources. So why do we use process coordination? So if we don't use process coordination, we actually give the processes free access to the same resource in a very uncontrollable manner. So this actually can lead to unexpected outputs, or we end up having inconsistent data. However, if we do coordinate them, we get them to access the data in a sequential, in a more controlled manner, and we can have an expected output or consistent data. So now let's look at semaphores. Semaphores are integer variables used to provide process coordination via atomic operations. Here, atomic operations refer to operations that cannot be interrupted or preempted. So semaphores here is actually a locking mechanism provided by the operating system. And the atomic operations here actually refer to two operations called wait and signal. At a conceptual level, wait is basically waiting for the semaphore to be unlocked so that the process can use it. And then signal, it is to unlock the semaphore, and it will tell the other processes that it is now free to be used. So what are the benefits of semaphores or process coordination? So first benefit is that we manage concurrent access to shared data or resources. And because of this benefit, we get the second benefit, which is to ensure expected output, or we have data consistency. And lastly, because of process coordination, it allows programmers to actually write very complicated or complex multi-processors code. Now let's move on to our case study. So the case study that we're looking into is actually YouTube view calculation. So YouTube is actually a free video sharing platform. And in a platform like this, there are usually two types of users. The first is the creator, which is the people that create video content. And the second are viewers, which is the people that watch the video content. Now, why is this case study important, and how does it relate back to process coordination? Because YouTube creators, they make money in various ways, but one of the ways is actually YouTube advertising revenue. And YouTube advertising revenue is actually dictated by the number of views. So the higher views that you get, the more revenue that you get. So in YouTube view calculation, coordination for processes is actually important, and we will see why soon.
Hi, my name is Wei Lun. Now I will introduce to you about how we distribute our tasks in this project among the group members. Okay, first, basically the task is mainly distributed into 7 types of category, which the first one will be the animation, second part will be the theory part, the third part will be the real-world application concept and idea, fourth one will be the presentation slide, the fifth one will be the video preparation and compilation of the video, and last but not least, the report preparation. Okay, so the animation part will be assigned to one of the group member, which is CHOON. He will help us to do the video for the animation in order to show how the semaphores work in real-world application, and also the explanation. After that, the theory part will be assigned to me, so I will find the theory part of semaphores and process coordination. And after that, Josh will be assigned to define the real-world application concept and idea which related to the semaphores. And after that, the presentation slide is prepared by all of us, and also the video preparation will be also prepared by all of us. And then SENG will help us to combine the video. And last but not least, the report preparation, we all will be involved in the preparation. Okay. For the next, so how we keep track our working, so we will do a Gantt chart in order to keep track our tasks. So in the work 11, we will draft the proposal and also the week 12. So we basically use 2 weeks to draft the proposal. Inside between these 2 weeks, I will searching for the theory part. So this involves for 3 weeks, and my friend Josh will searching for the real world application and study using 3 weeks. So between the week 12 and week 13, so we will coordinate with SENG in order to do the animation. So the animation basically took 2 weeks, which is week 12 and week 13. After we doing the animation, also we preparing the slide for the presentation. So this also occur in week 12 and also week 13. After week 13, week 40 we used to preparing the presentation video. So we will record the video and do the combination, which will help by our member SENG will combine all of the video. So after the video is done, we will move on to the report preparation. So this will done in the week 15. So basically we have organized 6 meetings totally in this project. For the meeting in week 11, we receive the topic. After that, we organize meeting in order to briefly discussing on the topic, which is process coordination. In 2 days after that, this is week 12, we discuss about the case study area, which we decided to focus on the semaphores in real-world application. So we create the Gantt chart in order to keep track our tasks, and also the methodology in order to understand overall flow of our project. So in next day, which is also the week 12, we propose a draft for the proposal, and checking the proposal. After we found that it's no problem, we submit the proposal. So in week 12 also, we distribute the task and do a discussing on animation. After that, in next week, which is week 13, we start the animation preparation and presentation slide preparation. So after that, in week 14, we do the presentation recording and combination of the video. So that's all of the 6 meetings. Thank you.
Hi, I'm Seng, and now I will help to present for the explanation of Semaphore about our case study, which is YouTube view synchronization. So first thing is, what is Semaphore? Actually, Semaphore can represent as an unsigned integer in operating system, and the integer change are atomic, which means that if a thread or process is increment or decrement the integer, another thread or process cannot interrupt before it finish the operation. So how to increment or decrement the integer that I mentioned just now? Actually, there are two operations to do so, which are the wait function to make the integer -1 and the signal function to make the integer become +1. So back to our YouTube view synchronization case study. If we set the semaphore integer to 1 and the YouTube view is assumed as 999 view, when a viewer is watching the YouTube video, the process will include of the wait function, the view +1 function, and signal function to implement. The wait function will immediately make the semaphore integer to decrement from 1 to 0, and meanwhile if another process wish to interrupt, it will not be possible because the semaphore integer is already become 0. Therefore, the new process will have to wait until the semaphore integer return back to 1, then it can start its turn to implement. So back to the first process, it will continue the YouTube view +1 function to make the view from 999 become 1000, and finally the signal function will turn back the integer of the semaphore from 0 to 1. Then the new process can continue. Whole process will be keep repeating again and again with the same algorithm by prevent the race condition occur. In conclusion, process synchronization is very important in an operating system because while executing many concurrent processes, it can help to maintain the shared data consistency. And for the Semaphore, actually is one of the powerful and well-known process synchronization tool in operating system. And I think that's all for me, and I hope this video can make you more understand on process synchronization and Semaphore. Thank you so much.